Okay, Coroneos 100 integrals, number 63. For this question, we need to integrate 9 plus x squared to the power of half. This is definitely a good question, and it's actually pretty hard. All right, so the first thing we do is let's change the power of half to the square root. All right, so once you've changed that into the square root, you start to thinking about how do I integrate this. Now, whenever you see a square root and you've got something like, a squared plus x squared, you start to think about trig substitution. So the method we're using is we need to get rid of the square root after we substitute a suitable trig values inside. One of the forming trig is 1 plus tangent square is equal to secant square x. So that's the formula we're going to use. So in this case here, we're going to substitute. Let x equals to 3 tangent theta. All right, the reason it's equal to 3 is because we've got a 9 right in the front. I want to, factorize the 9 and take out the 9 outside the square root. Okay, so we'll start with this, all right, and we'll start to prepare the integration. Okay, so dx is equal to 3 secant squared theta d theta. All right, and then we can now substitute everything back inside. All right, we should get 9 plus x squared. Now, x squared should be 9 tangent squared theta times by dx. And dx is equal to 3 secant squared theta. d theta. Okay. All right, so let's continue. All right, so what's inside the square root now can be changed using the Pythagorean identity formula for trig identities. That gives you 9 secant squared theta times by 3 secant squared theta d theta. Okay, so now we can find the square root of 9 secant squared theta. That is equal to 3 secant theta multiplied by 3 secant squared theta d theta. And then if we combine the coefficients, we get 3 times by 3, which is equal to 9. And at the end, we've got, we need to integrate secant to the power 3 theta d theta here. All right, so we still haven't finished. We use the substitution method to change the square root of 9 plus x squared back into now secant cubed theta here. All right, so to integrate this one, we need to use integration by parts. So it's definitely say it's a hard question. Okay, so we're going to change secant cubed theta into secant theta, secant squared theta, d theta. All right, we're going to use integration by parts. Now we let u equals to secant theta, and u dash is equal to secant theta tangent theta. V dash is equal to secant squared theta, and if we integrate secant squared theta, we should be able to get tangent theta here. Okay, all right, so now use integration by parts. We need to multiply these two together. I'm just going to put a bracket around. Okay, so that gives you secant theta tangent theta minus, and we need to integrate the product of these two, which gives you secant squared theta, secant theta, and tangent squared theta d theta here. All right, and close brackets. Okay, now let's continue. We can expand this bracket. All right, now we need to change this one back into, we know tangent squared theta is equal to secant squared theta minus 1, so we're going to change that one there. So at the end of the day, you can actually see that we change this one back into secant cubed theta later. All right, so that gives you secant squared theta minus 1, d theta. So that gives you 9 secant theta tangent theta minus 9 integrate secant cubed theta minus secant theta here, d theta. All right, let's keep expanding. So we get minus 9 integrate secant cubed theta d theta. So let's just separate these two integrals. So that gives you plus 9 and integrate secant theta d theta here. All right, so now once you get up to this stage here, what you need to do is start to compare. We started the questions with this one here. So this is what we did. We started the question with this one, and then we now get to this point. Okay, All right, but if you have a look at it, these two terms are equal to each other. All right, I don't know if you actually noticed this or not, but these two terms are actually equal to each other. Now, which means what I can do is move this term, for example, just drag this term here to the left-hand side, okay? And then we can move the term here over to the left, all right? And we should be able to actually find out the answers to integrate what is secant cube theta here, all right? So let me just rewrite this. So we start with 9 integrate secant cube theta d theta, and that is equal to now is equal to 9 sect theta tangent theta minus 9 integrate sect cube theta d theta plus 9 integrate sect theta d theta. Now, if you look at this one here, each of the term has a 9 attached to it, so we probably can just get rid of the 9. I don't need the 9 to be here, so let's just remove all the 9s there. Okay, all right, so we now get to this point. Then we can move this term over to that side. We should be able to get 2 lots of integrate sect cube theta d theta is equal to sect theta tangent theta and plus integrate sect theta d theta. Okay, all right. So now all we have to do is think about how to integrate sect theta. In the previous videos, there's a formula that you need to remember for integrating sect theta. You need to times both the top and bottom of the fraction by this term here, and that will give you the logarithm, okay? So we know the answer straight away. It's just kind of the formula, so I'm just going to write down the answer that is going to be log and absolute value sect theta plus tangent theta and plus c. Okay, all right, and we still haven't finished. We need to move the 2 all the way to the right. So if we integrate sect cube theta d theta, we get a half sect theta tangent theta plus half ln absolute value sect theta plus tangent theta plus c. Okay, again, we still haven't finished. This is just integrate sect cube theta. We've got 9 sect cube theta here. So what we need to do is move this one and do a substitution back into here. Okay. All right. So it's a crazy question. So let's just start. Put this one back. We've got 9 sect cube theta d theta, which equals to 9 over 2 sect theta tangent theta plus 9 over 2 ln absolute value sect theta plus tangent theta plus c. Now we still haven't finished, okay? So the question, we start with the question with the variable equals to x, and that was our substitution as a beginning. That's our substitution. So what I need to do is replacing all the theta here with respect to x, okay? So the answer should be in respect to x. So I'm going to do that as well. All right, we started with x equals to 3 tangent theta. So therefore, tangent theta is equal to x on 3. And from here, we should be able to draw a right angle triangle and use Pythagoras to give us the ratio of the hypotenuse. That's the square root of x squared plus 9. All right, so now we can continue. That's 9 over 2, okay? And we start to find out what does each of the term equals to. Now, sect theta is reciprocal of cosine, all right? Cosine is equal to 3 over square root of x squared plus 9. This time is the reciprocal, so that becomes square root of x squared plus 9 over 3. Multiply by tangent theta, and we know that's equal to x on 3. That's easy. Next, we have 9 over 2 ln absolute value, and we're going to do the same thing here. Okay, and it's x on 3, absolute value, and plus c. Okay, all right, and now what we can do is we can simplify it. Otherwise, you can leave the answer like this, but we can simplify this. 3 times by 3 is equal to 9, which you can cancel with this 9 over there. So that gives you half as the half square root of x squared plus 9. And there's also an x here. Almost forgot about this x. So let's just put x in between. And plus we still need to simplify this one. Now to simplify this one, we can just make the same denominator here. That's fine. So that just gives you 9 over 2 ln absolute value of square root of x squared plus 9 plus x over 3 and plus c. Now you can even further simplify what's inside, because using the log laws, you should be able to get ln absolute value of x squared plus 9 plus x minus ln 3 here. And ln 3 is just a constant number, which is going to combine with this constant number c here. So you can further simplify what's inside, but I feel like this is good enough. All right, it's very simple, and that looks right. So that's how you do this question here. Definitely it's a long question, as you can see stuff on the very beginning and all the way to the end. So during the process, we use the substitution first. We change that into the trig ratios, so it's a trig integration, and then we use integration by parts. After we get to the result, we still need to replace the x back inside, use the Pythagorean identities, Pythagoreans, okay, so the Pythagoras, and then also we need to simplify it towards the end. Okay, thanks for watching.